This is Stanton and I. Well, this is Stanton and I. For the first Introduction to Unity course, we decided to team up even though it was an individual project, which may have been breaking the mold, but we figured we could be a little more ambitious, and we had a similar idea for what we wanted to do. The original demo had the player using a keyboard to avoid asteroids and fly their shuttle into the landing bay of a carrier. We wanted to take this concept into VR and improve on the experience. Early in the discovery phase, Stanton pitched a control scheme that, while amazing, seemed beyond anything we'd be able to figure out. In the end, Stanton succeeded in making it a reality. A virtual reality. He'll explain how he did it in a bit. We didn't want to just port our original experience into VR. Aside from updated controls, we wanted to improve the visuals and allow the player to walk around the shuttle. The idea being that this could be a proof of concept for a more expansive game. I focused on the models, sound, and the asteroid spawning system. With hundreds of asteroids randomly spawning between the player and the goal, I reduced the poly count of the asteroids by 75%. To better suit mobile performance, the playfield was optimized to a smaller size. The prefabs were rearranged so that the empty parent is doing the rotation and the child asteroid has the rigid body and collider components. Before these courses, neither of us had written a single line of code, so getting C# to do what we wanted was always a challenge. We've come a long way since the fall of 2020. We started with a crude submarine-like shuttle that was refined over 7 months. I had hobbied with Blender for a year before this, so this made it a lot easier to bring our visual ideas to life.
Hey guys, finished testing that game yet? I've got another one I need designed.
We just finished level 3 and need to tighten up the graphics a little bit.
Great.
I focused on the interior scene and quickly found my ambitions couldn't keep up with the timeline of the course. Ideas of repairing the ship were reduced to simply rebooting the computer. Cooperative play was dropped, hopefully to be tested in the future. I spent some late nights reviewing old courses and getting my various scripts to communicate. Hopefully the end result displays a desperate atmosphere that gives a glimpse as to what we could build. It's been a rewarding challenge. Endless concepts were studied, things broke, and when I couldn't find a fix, Stanton had the patient disposition to methodically search with me for the solution. Stanton focused on the hard part, making the shuttle fly, which he'll explain.
I've always loved the concept of exploration in games. Playing Manhole on my dad's IBM was an early childhood memory. Then it grew into Wing Commander, Monkey Island. Flying in space tends to be programmed to work kind of like how we fly in atmosphere, a variable thrust moving us forward while we control 2, maybe 3 axes of rotation. Games like Star Wars Squadrons are already doing this really well. But I wanted the movement in Hullbreach to feel less on rails like Star Fox and more like Kerbal Space Program. I also wanted Hullbreach to feel immersive. So the question I asked was, how can we create systems that don't require physical boundary or tension? A joystick is a fantastic system to control rotation. It allows float values to be applied for X, Y, and Z, but what about actual translation? What about the movement? The NASA Space Shuttle uses 2 joysticks, left for translation, right for attitude, and maybe once we all have 3D printers in our homes, we could release a game that comes with 2 separate joysticks. But even if we could ensure each player had 2 joysticks, is this really the best way? Is this how a ship of the future would be designed? In my effort to make Hullbreach immersive, I opted to create a holographic control system that displays a small model of the ship and shows a holographic representation of how the ship is moving in space. Before beginning the work of porting our WebGL game into VR, I knew this control system needed to be refined and working properly. So we set up what we affectionately called our virtual playground. It was a shared scene that Clark and I could experiment in without the pressures to follow any type of official game design. My first goal was to get controls working remotely without being inside of the ship. I set up 2 cubes, duplicated them to have origin point references, created slightly larger spheres to indicate a boundary range, and rigid bodies so that I could grab the cubes. For the right cube, I froze the rigid body's movement, and for the left cube, I froze the rigid body's rotation. This worked fairly well, and I was able to script them to return to their original position and orientation upon release, but I also had the issue of the translation controller moving away anywhere I took it, far outside the fictional boundaries of a holographic projector. Configurable joints allowed me to specify limitations to the controller's movement, but here's the thing. The XRGrab interactable script that we used brings any object you grab into the root of the scene hierarchy, thereby unparenting it from whatever rigid body its joint was just connected to. So I split each controller in two. One part, the visible part, remained in the scene, but each holographic controller now had an invisible cube positioned right there. So when the player reaches out, they aren't actually grabbing the holo controller, they're grabbing an invisible cube that the holo controller follows. In the case of the rotational controller, it actually uses a look at script to orient itself to a smaller invisible cube a short distance out in front. And what I love about this is that with the offset grab interactable script, the player can grab the controller from any hand position or rotation and then rotate in whatever position feels most comfortable to them. There's no lining up your hand beforehand. The translation controller works a bit differently. It has a script that just follows the invisible cube in space. Now that I could move the controllers, I needed a way to measure them. These measurements would then be applied to the rigid body of the shuttle itself. After way too many evenings spent scrolling through message boards trying to understand the differences between quaternions, Euler angles, local Euler angles, and angles that were shown in Unity inspectors, I finally managed to write a script that takes a local Euler angle of the holographic controller, divides it by a variable maximum rotation angle, clamps it between -1 and 1, and then applies that as a float as a relative torque or force value to the shuttle. Of course, once I put all this into a moving shuttle, everything got messed up. Children inherit the rigid bodies of parents, and so having movement or rotation locked on either controller caused the shuttle to also lock up. I ended up removing the rigid bodies from the holo controllers completely. I also struggled with jitteriness of the translation controller. I suspect it's a combination of issues. Maybe too many objects attached to the shuttle. Maybe it's just too much physics for Unity to calculate at a time, and maybe it's a rendering issue. I don't really know. I still wonder if it'd be better to not use physics at all. Maybe come up with some sort of translational movement script that looks and feels like force and torque, but actually isn't. I also wonder if there's a way to just measure the hand movements of the players in real life controllers, then just apply those to the shuttle. That way I wouldn't need to hassle with actually grabbing any game objects. In the end, my solution was to make it the player's problem. I wrote a line of incoming dialogue that warns the player that the left holo controller was damaged. It's not ideal, but hey, we were on a deadline.
And that is how two guys with no previous experience in coding or game engines built a functioning, half-decent virtual reality demo. And many thanks to Nick, Mark, and everybody else who's helped us along this 11-month journey. It's been rewarding and it's been a lot of fun.
Hey, I can't believe we got jobs doing this.
I know. And my mom said I would never get anywhere with these games.